Imagine standing outside on a quiet night, the moon rising slowly above the horizon, pale as frost and patient as breath. Its light spills across rooftops and trees, touches windows, slides over sleeping streets, and for a moment the world feels gentler than it did in the day. You look up and see the familiar face, the seas and bright craters, the same pattern that people have traced with fingers and stories for as long as there have been stories. Yet, what you do not see, what no one has ever seen with their eyes from the ground, is the other half. The moon keeps one side turned toward us, and one side turned away, held by gravity in a long and careful dance, its far side hidden behind a veil that only machines have lifted. The words far side of the moon carry a hush with them, a suggestion that something is being kept, not in secrecy, but in simple distance, and that if we could only walk around the corner of the sky, we might find a different world waiting there. The reason for this hiding is not magic, but time and tides. Long ago, the Earth tugged on the moon's crust and slowed its spin until one rotation matched one orbit, so the same hemisphere always faces us. If you stood on the far side, you would never see Earth hanging in your heavens, never watch our planet rise and set as a blue lantern. You would see only stars and the sun, and the long arch of the Milky Way. For millennia, that absence made the far side a canvas for imagination. Some cultures filled it with spirits and palaces, some with gardens, some with deserts. Poets dreamed that the hidden face might hold the answer to a question they could not name. The mystery endured until the 20th century, when a small spacecraft slipped behind the moon and turned a camera toward the darkness. In 1959, the Soviet probe Luna 3 flew past the far side and sent home the first photographs. The pictures were blurry and streaked, printed on flimsy paper, and developed by the spacecraft itself, then transmitted line by line, as if the moon were being sketched in static. Yet, even through the haze, the surprise was unmistakable. The far side did not match the face we knew. It was rougher, older, almost completely covered in bright, battered highlands. The wide, dark seas of cooled lava that make the near side look like a face were nearly absent. Our moon, which had seemed so familiar, had two personalities. One we had lived with, and one that had waited in silence. People stared at those photos in newspapers and textbooks, and felt the thrill of discovering a room in their own house that they had never known was there. Over the next decades, spacecraft returned with sharper images. Orbiters traced the shapes of craters and mountains, mapped the thickness of crust, measured differences in gravity, and found that the moon is lopsided inside as well as out. The near side is thinner and coated in basaltic plains. The far side is thicker and more mountainous. One idea says that when the moon was young, it may have been splashed by a companion moon that merged gently and thickened one hemisphere. Another says the near side stayed hot longer because radioactive elements were concentrated there, so lava could break through and fill the basins. Whatever the reason, the far side preserved more of the solar system's earliest scars. To look at those highlands is to look back through deep time, across more billions of years than there are words to count, and to read a record that no wind or water has ever erased. The far side is precious for another reason. It is a place where the universe can be heard. Earth hums with radio noise from phones, radars, satellites, and all the invisible threads that tie our modern lives together. The moon's bulk blocks that noise. On the far side, the airless silence is not only soundless, but radio quiet, a natural shield against our chatter. Astronomers dream of unfurling a web of antennas across a crater there to listen to the most delicate signals, to the whisper of hydrogen left over from the first stars, to the drifting music of the cosmos before galaxies grew bright. A telescope on the far side would hear like no instrument on Earth can hear. To imagine standing next to it at lunar night is to imagine a sky so full of unbroken stars that it feels like you could lean against them, the universe speaking softly in a frequency that no wind disturbs. In 2019, China's Chang'e 4 mission became the first to touch the far side soil. The lander settled into von Karman crater, and the small rover U-22 rolled down a ramp and began to creep across the gray regolith. Because the far side cannot talk to Earth directly, a relay satellite waited on the far side of the moon's orbit, passing messages around the lunar bulk like notes between two quiet rooms. The rover photographed shards of impact melt, traced tracks across pebbled dust, and sniffed at the ground with instruments that could sense hidden layers. Step by step, it showed that exploration there is possible, patient, and gentle. The far side also holds one of the grandest features in the solar system, the South Pole Aitken Basin, an impact scar so wide it would stretch from one end of a continent to the other, and so deep it may expose rocks from the moon's mantle. To stand on its rim would be to look into history's well. Samples from that basin could tell us how the moon cooled, how it differentiated into crust and mantle, whether the early inner solar system was bombarded all at once, or quietly over long ages. From orbit, we see the basin's outline and the swirls of minerals that hint at layers below, but the ground truth waits in the dust. When Apollo astronauts orbited the moon, they passed into the far side's shadow every 2 hours. In those minutes, the radio went dark. The voices from Houston faded. The beeps that measured time faded. And there was only breathing in the headsets and the hum of the capsule. Some astronauts wrote that the darkness felt like stepping out of the world. Others said they felt a calm more complete than any they had known, as if the machinery itself were holding its breath. After the curve of the moon slipped past the window and the crescent of Earth returned, the radio clicked alive again, and ordinary sounds flooded back. Those journeys carved an emotional map that matched the physical one, a rhythm of separation and reunion that made the far side not only a place on a globe, but a place in the heart. Because it is hidden, the far side has long attracted myth. Shadows in photos are mistaken for towers. Aligned boulders are called walls. Tricks of light become faces or domes or paths. Our eyes are hungry for pattern, and our stories are hungry for wonder. Yet the truth we have found there is quieter and more durable. What hides on the far side is not a city or a secret fleet, but the shape of time itself. Each crater is a sentence in a history book, written by impacts and lava. Each ridge a line that records the cooling of a young world. The far side does not need to be crowded with fantasies to be mysterious. It is mysterious because it exists beyond our daily horizon, and because its silence invites us to fill it with meaning. Think, for a moment, about what it would feel like to build a home there. Imagine a small base tucked into shadow near the South Pole, its modules buried under regolith to block radiation. Outside, the sun skims the horizon for days, painting long shadows over ridges and ice. Inside, the air tastes recycled and warm, and you share the space with a handful of people who know how to listen. At night, you step out in a suit, and the sky hits you with more stars than you remembered could exist. There is no blue earth to greet you, no reminder that your world is just over the hill. You carry that knowledge in your chest instead. You collect a sample, check an antenna, watch the dust sparkle slightly as it catches sunlight. The far side is not hostile, only indifferent. And in that indifference, there is a kind of honesty. Living there would change the way we think about time. Days are long, 2 weeks of sun followed by 2 weeks of night. Work would follow a rhythm unlike any on Earth. You would mark your days not by clocks alone, but by the crawl of shadows across a crater wall, and by the crunch of boots in dust next to a track you left a month before. You would learn the map of a sky that has no Earth in it, and you might find that the absence becomes a presence of its own, a space that invites thoughts you never had room for before. A far side radio observatory would grow like a garden, Lightweight antennas could be rolled out across the ground in patterns that look like petals or waves. Cables would snake along trenches to a quiet building that hums with receivers. When solar storms rise, the instruments would rest. When lunar night falls, they would listen harder, their electronics cooled by the vacuum. From such a place, we could study the universe's childhood, a time before galaxies when the first atoms began to glow. We could watch distant magnetized planets and listen to auroras on stars. Knowledge would flow out of the quiet, and the quiet would remain. The far side also offers clues to our own beginnings. The moon and Earth likely formed from the same violent collision between a young Earth and a Mars-sized body. By comparing rocks from the far side to rocks from the near, by learning how heat and crust were distributed, we sharpen the story of how our planet became a place where oceans could settle and continents could drift. In that sense, what hides on the far side is not only lunar history, but a chapter of Earth's autobiography written in another language. There is a gentler hiding as well. The far side hides a feeling we rarely have on Earth anymore, the feeling of being completely away. On our planet, even in deserts and high mountains, the signals follow us. The far side leaves you with only the stars, your companions, and the faint murmur of machinery. Some will find that unsettling. Others will find it healing. Silence has a way of opening doors in the mind. Of course, not all of the far side's secrets are cosmic. Many are simply geological. There are sinuous rills that curve like frozen rivers, ejecta blankets that splash outward from ancient basins, and fields where glass beads from impacts sparkle under sunlight. There are ridges that fold like the pleats of an enormous garment, and boulder fields that look as though giants once walked there and dropped their pockets. A person could spend a lifetime crossing from one scar to another and never run out of details. The beauty of such a place is not that it shouts, but that it persists. As more nations plan missions to the moon, the far side will likely see visitors more often. Robots will scout routes, prospect for ice, and test ways to build habitats from local dust. Humans will follow, slow at first, careful, learning again how to be gentle in a place that is both fragile and harsh. We will argue about how much to touch, how much to leave alone, how to treat a landscape that has waited already longer than all of human history put together. There will also be nights on Earth when people step outside and look up, and nothing will seem different. The face of the moon will be the same it has always been, but some of those people will know that just beyond that edge, out of sight, someone is walking under the same stars, placing markers on a map that used to be a blank. The knowledge will make the familiar more beautiful. The near side will not be diminished by knowing the far side. It will be deepened. In all of this, the far side teaches a quiet lesson about limits. It shows how long a boundary can hold and how carefully it can be crossed. It shows that a secret kept by nature is not a trick, but a chance to practice patience. We did not force the moon to turn. We learned to go around. We did not demand that it speak. We learned to listen from another angle. The rewards are richer for that humility. So ask again, what is really hiding there? Not dragons, not cities of glass, not alien lights that flicker when we look away. What hides there is the shape of deep time, the map of ancient collisions, the chemistry of stones that have watched 4.5 billion years pass in slow detail. What hides there is the cleanest radio sky nearby, the quiet where the universe's first songs might still be heard. What hides there is an invitation to build carefully, to live simply for a while, to pay attention to textures and shadows, and the way a footprint can last for ages. As you let these thoughts drift, picture yourself standing on the far side at lunar night. The stars are so many they do not twinkle. They simply glow. The ground is a powder that keeps the memory of every step. In the distance, a small antenna field waits like a garden of wire. The Earth is invisible, yet you feel its pull in your chest, the way a traveler feels the pull of home. You do not need the view to know that it is there. You breathe and you listen, and you feel the small tug of gravity holding you gently to a world that is not your own. The far side of the moon is hiding in plain sight. It hides behind tidal lock and patience, behind distance and history. It hides myths and dreams. It hides science and silence. It hides a set of answers that no hurried glance can find. It hides a chance for us to become slower, kinder explorers. It hides a truth about ourselves as well, that we are most alive when we lean toward the unknown and let it teach us how to see. So tonight, as you watch the moon climb and pale light gather on rooftops and fields, remember that half of that light comes from a face you can never see. Remember that beyond the familiar pattern lies a terrain of mountains and scars, craters within craters, and a quiet that could hold a lifetime of listening. Remember that mystery is not a wall, but a doorway that opens when you approach with gentle steps. Let that thought carry you toward sleep. Let it soften the edges of your day. Let it remind you that the universe contains rooms you have not yet entered, even in places you thought you knew, even in the steady light of the moon.